I'm Janis Kamars. I joined Primekss 13 years ago. Before that, I was already bored just to replicate things written in design code and saw a great opportunity to go a step forward by joining Primekss research team on the way of research, innovation and new production techniques. This is me, skippering the cyborg during the race. Construction, especially concrete industry, is much like sailing. There is always a great room for tweaking and adjusting your rig in continuously changing complex environmental conditions to maintain the maximum boat performance. Both can keep engineering minds busy for days. Besides designing and sailing, I am a PhD candidate and studying steel fiber reinforced concrete structural fire resistance in Riga Technical University. So let's proceed. I would like to start with traditional today's practice, how industrial slabs are designed, what practices are implemented to compensate problems raised by material shrinkage. Typical situation, curled slab due to the shrinkage. Especially curling gets worse if your slab thickness is going down. Any joint of the slab made from regular concrete is going to open. In case of traditional extended joint-free systems, where joints are placed at approximately 30 to 40 meters apart, joint will open significantly, even up to 30 millimeters. This is where armored joints came into the game to protect slab edge and load transfer across the gap between separate slab parts. Here you can see example of tight working joint. Armored joints that ensures load transfer in case of forklifts crossing it. System is engineered well. You can see how stress redistributes across the joint steel elements from one side to other. But after few months, shrinkage takes place. Here you can see a typical equipment passing of curled armored joint. Passing the connection, equipment bumps up. You should slow down your operation, not damage goods and equipment. After the landing, wheels hit the opposite side of armored joint and is causing a damage to your equipment, wheels and goods, significantly slowing down production and even misguiding robotic equipment. Such joints should be regularly grinded and equipment fixed. Summing up, this solution is inefficient. Slab is thick, detail is expensive. Armored joints does not solve the major concrete problem, shrinkage. Using Primekss system, first of all, slab can be designed thinner. Extra thickness to minimize shrinkage caused effects is not needed. Secondly, joints mainly are required to separate daily casting areas. It means a lot less joints in general. With Primekss, sophisticated and costly armored joint profiles are not needed. It can be used back-to-back casting with dowel system only. There is no need to protect edges of Primekss slab, as joints will not open or curl. Details are much more simple, costs a lot less and provides the same efficiency. Now let's focus on robots and automation. These are most demanding technologies asking for high specification slabs. Today I'll talk about these three types of automated warehouses. Wire-guided automated systems, high bay, autonomous mobile robots. I will give more insight what benefits Primekss system ensures for all these types of buildings. Let's start with the wire-guided vehicles. Existing two-layer mesh systems is practically impossible to change to wire-guided technology. So-called fiber floors and extended joint systems have curled and/or widely opened joints all over the area, making much more difficult and expensive to transform such slabs to automatization. If steel mesh design is in use, there is need for extra thick slab to ensure proper placement for the wire and prevent interference of equipment guiding signals. This also requires to not compromise top mesh concrete cover or even damaging and losing structural load-bearing capacity of the slab. Induction wire typically requires as minimum as 60 to 70 millimeters concrete cover to be present instead of available 25 to 35 millimeters of the existing slab structures. Curled saw-cut joints need additional grinding for smoother operation and may require compensation loops across the joint to cope with the dynamic response. Main capabilities of Primekss slab is flexible road designing for robots, no limitations in wire placement or refitting old wire layout. This is one of our first projects in Norway. Back in 2009 it was built as a regular warehouse, but few years later, during regular inspection visit, we found out that slab has been repurposed for wiring guided automatization. Due to the Primekss technology, slab was already at that time ready for future technology implementation. Induction wire typically is positioned in between tires and in the middle of the aisle. Such positioning not compromising structural capacity, where it is needed the most, directly below tires and shelf racks. Here you can see fully refitted warehouse with automated goods handling equipment. During my last visit this year, I saw that some areas were rearranged successfully for the second time. Let's proceed to another type of warehouse automation, high bays. Slabs on long high bay aisles is difficult to place in one pour. As we know, one of the most important criterions in such projects are structure potential to withstand loads, ensure deflections in accordance with FM standards. Little or no deformations of slab is permitted, and absence of joints in a craneways is needed to allow warehouse operate at full speed. Shrinkage makes design challenging, especially for robot rails and deepenings, where in a typical solution different level structures are connected with joints such a way making the whole structure less stable in long term. To guarantee this, regular floor systems use a lot of additional steel and structures are designed thicker. With traditional concrete system in extra long aisles, there is a requirement for shrinkage compensation joints. This leads to interruption of racking system, doubling shelf structure and efficient use of space. However, Primekss technology allows to eliminate joints to have more efficient structures. This means less building volume, faster operations, optimized racking system. Primekss slab has much higher modulus of elasticity, providing smooth operation in long term. That is what allows Primekss design to be thinner and efficient. A good example of high bay warehouse project with Primekss slab system is PrīmX Logistics Center in Finland. In more than 200,000 square meter area, there are placed several automated systems that altogether work smoothly due to stable work platform. Next, optical sensors guided mobile robots. Again, no joint or jointless profile slab are very important. Robots and their wheelbase are smaller than traditional forklifts, so technology is even more demanding for slab flatness tolerances. For such a project, a good example is Gold Bond project in Israel. Initially, for this project, Primekss floor was installed under different specification. Suddenly, agreed tenant changed his intentions and didn't start operating in warehouse. As floor was future ready for automation systems, for the client it was easy to find another tenant with even more strict specifications for the floor slab without financial loss. In this video you can see Gold Bond warehouse in operation. And now let's focus on pile supported slabs. Shrinkage stress in traditional concrete reduces load-bearing capacity of cross-section and puts entire structure in tension, requiring building to be divided in smaller parts. Taking into account this phenomena, distances between piles must be shortened, cross-section extra reinforced and dimensioned thicker. With Primekss there is an option to reduce the slab thickness or enlarge distance between piles, thus optimizing design. Slab can remain in the single panel, ensuring overall stability of the building and technology. In case of used project shown in the pictures, optimized pile grid was developed. Piles concentrated in places with higher dynamic loads, example under robot rails and rack legs, less pile density and slab thickness in places with less load concentration. In result, efficient and cost-effective structure. Here's another great example of similar structure. 50 x 200 meters single panel high bay platform supported by piles in Latvia. Another efficient use of Primekss technology is freezer subfloor construction. Heated subfloor is required to prevent freezing of subsoil during freezer operations. To prevent that happen, there are built heating pipe system under the heat insulation. Complexity and time for building these systems is very dependent on initial slab design. Jointed slab systems must be divided in separated subsystems, that in order leads to more complex, time-consuming and costly solution. In case of Primekss, separated slab systems can be merged. It means no joints and more efficient heat-tip contour design. In case of high bay freezers, Primekss is even more beneficial to slab design. And now, liquid and gas tight solutions. Typical way of solving water and gas tightness in structures is by using time and labor consuming expensive membrane installation. With Primekss technology it can be done more efficient. By utilizing two main properties of technology, Primekss system is crackless and no or minimal amount of joints with special detailing gives possibility to achieve water and gas tightness of structures. Following this approach, we built efficient slab in microsource fertilizer warehouse, which was meant to prevent ingression of fertilizer in subsoil. Here's another example from project in Lithuania. Liquid-tight emergency reservoir for epoxy resins under silos to prevent leakage of chemical components into the subsoil. Here's an example of Primekss watertight raft, World Trade Center, Helsingborg, Sweden. Watertight properties of system and elimination of expensive and time-consuming membrane installation allowed us to complete building submerged foundations in several weeks ahead of original time schedule. Benefits Primekss system provided in the current project: saved weeks of construction times, savings on waterproofing membrane, less manpower involved in construction, saved approximately 50% of the steel amount comparing to the original traditional steel mesh reinforced concrete solution. Gas-tight systems works according to the same principles as for water and liquid-tight solutions. In case of Primekss, gas-proofing membrane is not placed under the whole slab as in traditional solution. Because Primekss is gas-proof, membrane is placed only in the day joints and details connecting slab to other structural elements. That again allows for more efficient design and meaningful cost reduction.